Okay, Assalamualaikum and good afternoon. So we shall start our class. As you know, I'm not going to teach you like the face-to-face class. Okay, so we just go to the exercise and then I will summarize summarize the whole subtopic for this week. Okay. Before that, still I have quite hectic schedule. Still, I don't have time to create your attendance in Google Classroom. Okay, don't worry about that. Okay, I'm not really what we call stress on that attendance. Okay, I will do it and then it will be abandoned lah from the week one until inshallah next week lah we start the attendance because still week one, week two still at drop. Okay, so you will be like in and out lah. Okay, so week three inshallah we will start with the attendance. Okay, so I will do backdated lah from the week one until week three lah in your Google Classroom, and then you just fill up that one. Okay, so we start. Okay, so before we go to the exercise, I just want to discuss the histogram here because it will be in your it is in your assignment. If you notice, I don't remember which question, but you have to construct the histogram for your data. Okay, so you have 4 set of data, so means that you will have 4 different histogram for each data. Okay. Okay, so in that question, okay, you have to determine the shape of the distribution. Okay, the shape of distribution for the histogram. So when you have histogram, this is the 8 common pattern for the histogram. Okay, so you have 8 common pattern for the histogram. Okay, so when you plot your histogram, then try to compare with this common pattern. Okay, and then you know lah what the shape of your data. Okay, and sometimes when we have a real data, it is like how I call the beauty of the data lah. The data will be diverse. We have variation of the data. Okay, you could have outlier. Okay, you have this. You should know lah what is outlier if you already go through all the notes for this week. Okay, you might have the outlier. Okay, outlier is a extremely large or extremely low data value, which is isolate from the range of your data. Okay, for example, that most of your data, it is between 50 to the 500, for example. So outlier could be like 1,000, 2,000, okay, even 900, 800. It could be the outlier because it is isolate from the rest of the data lah. Okay, so when you have that kind of data, then you might not get okay exactly pattern okay as this 8 lah. Okay, okay, your data might you might not get this exactly pattern. Okay, so what you need to do, try to identify which one is the closest one to your data lah. Okay, which one is the closest one to your data. Okay, you might not get exactly as this one, but it should be close to all these 8 pattern. Okay, so when you write your answer letter, when you analyze your histogram letter, try to get the closest pattern that you can okay, based on your data. Okay, or maybe you can write like, for example, that your data looks like bimodal here. Okay, so bimodal, you should have actually exactly we have highest bar, 2 highest bar here at the same height. Okay, it should be exactly at the same height, but maybe you get this, the second bar here, the second highest bar here could be larger than this one, for example, highest than this one. So maybe you can write here approximately bimodal. also okay lah. Close to the bimodal, but it is not bimodal, exactly bimodal. We cannot write that. We cannot write it as a bimodal. So what you can do, approximately bimodal. Okay, that one for your assignment lah. Okay. And what you can comment on the Instagram, you can comment on the highest data that you have, okay, highest number that you have. You can talk about the lowest number that you have based on the Instagram. You can talk about the moderate number, okay, of your data based on the Instagram. That's what we meant by comment on the histogram. Okay, you can discuss the highest data, you can discuss the lowest data, or maybe you want to discuss the most of the data in what range based on your histogram. Okay, that's how we comment on the histogram. Okay, should get lah. Okay. The next. Okay. So this week it should be start from 1.2.5, but it just what we call information that you have to know. Okay, so you can always read this one lah, this part. Okay, the information that you should know how to present, how to analyze your data. Okay. But in chapter 1, we will discuss the descriptive statistic, how to analyze your data by using descriptive statistic. So we calculate some numerical value to represent your data. Okay. When we go further, chapter 2 and onward, okay, it will be statistical inference, which is inferential statistic, the one that we discussed before. Okay, we will go to the inferential statistic. Okay, you have the confidence interval, you have the hypothesis testing. Okay, your part 2 letter of your assignment, it will be hypothesis testing. You can hear me, right? Boleh? Boleh dengar saya?
Yes, yes.
Boleh.
Yes, betul.
Yeah, it is like talking to the laptop now. Okay, so interrupt me if you have any question. No need to wait until I ask you whether you have question or not. Okay. So
Okay,
we
madam.
have. Thank you. Okay, so 1.2.6, it is a last step for the statistical methodology here. Okay, so the last step is to close your study with some conclusion or decision. Okay, so similar to your assignment, the last question, it is about conclusion, what you can write. Okay, based on the data that you have, based on the study that you have, what you can conclude. That's a good report. Okay, we wrap our report with the conclusion or some decision that you can make to solve the problem that you have. Okay. Okay, so we have 1.3 review on the descriptive statistic. Okay, so one of the method that you can use to summarize our data, to analyze our data, we calculate some value lah. Okay, so descriptive statistic, we have what we call here, three measures. Okay, we have the central tendency. It is about middle of your data set. Okay, you have mean, you have median, you have mode, and also mid-range. Okay, and then we have measure of variation. Okay, so measure of variation, we measure the variability of your data set. Okay, variability means that how consistent of your data set, how good of your data, okay, how consistent of your data, how separate the data set. Okay, we use measure of variation. Okay, so we have a few values here. We have range, we have variance, we have standard deviation, and also coefficient of variation. Okay, and then the last measure, we have measure of position. Okay, so we use measure of position to get information, the location of our data. Okay, location of our data. So we have quantile, we have decile, and we have percentile. So we have three measures here. Okay, so quantile here. Okay, quantile here, it is not only to get the information about the location of our data. Okay, we also use quantile to measure the variation. Okay, so based on quanta here, also we can discuss the reliability of your data set. Okay, we will go through later. Okay. Mm. Okay, so you should practice how to use your calculator. Okay, especially for the mean and variance and also standard deviation. Okay, so we have all this type for these two kind of calculator. If you have different than these two, then you should Google. Okay. Okay, so when we go to the chapter 2 and onward, we are not going to ask you how to calculate manually for the mean, variance, and standard deviation. Okay, so what we can do here, we key in the data that you have in calculator, and then you can get the value of mean and also variance and standard deviation. Okay, based on the calculator, you will get the standard deviation value, and then in order to get the variance, you just square that value lah, and then you will get the variance. Okay, so in your calculator, it will be two value. Okay, if you can see here, it will be, okay, so as bar it is for the mean. Doesn't matter the data that you have is a population data or the sample data, you will get similar value for the mean. Okay, because we have similar formula for the mean. Okay, so that one shouldn't be a problem, but the problem will be at standard deviation here. Okay, the standard deviation here. Okay, so calculator will give you both. The first one here, okay, population standard deviation. Okay, population standard deviation, similar to the here. Okay, sigma x. Okay, and the third value here, this one, it is sample standard deviation. So similar to here, it is a sample standard deviation. Okay, so calculator cannot distinguish the data that you key in, the data that you key in. It is sample data or population data. So it is your job lah to choose which value that you want. Okay. So means that you have to know the data that you key in, population or sample. If sample, then use the third one, sample standard deviation. If your data is a population, then use the second one. Okay, population standard deviation. Calculator will give you both. Okay, dua-dua you akan dapat both value. So you punya job lah untuk choose which one that you want, whether sample value or the population value. So how do we know the data given is a population or sample? It is based on the whole story that you have in that question. Okay, that one we already discussed before. Okay. Okay, so you have measure of central tendency here. Okay, you have the mid-range, how to calculate manually. It should be minus or plus. Okay, should be plus here. Okay. So rough estimate of the middle, your mid-range, and then we have mean. Okay, so tak keluar jadi simbol. It's okay lah. Okay, you can refer to the notes later lah. Okay, here should be mu. Okay. Okay, so if you can see here, we have similar formula for the population mean and sample mean. Both it is about summation of the data value. Okay, find the summation of the data value and then divide by number of data. Okay, so similar to the sample here. Okay, summation of the data value and then number of sample. Okay, so how do we distinguish based on the notation? As I said, okay, if the value that we calculate, we have the notation, then we should use the notation because only notation, because only by using notation we can distinguish, okay, whether the value that we have is a population or sample value. Okay, So we have similar formula for the mean, population and sample mean. That's why in your calculator we have single value for the mean. It doesn't matter the value that the data that we key in is a population or sample. Okay, dia akan bagi similar value because of we have similar formula here. Okay. Okay. So we have median here. Sama tak keluar. Okay. So I try buka another one. Okay, sini keluar. Okay, so we have median. Okay, median it is about what you call? It is we are looking for the middle of the data. Okay, but median is about location of your data. Okay, middle number. Okay, it's a middle number of the n ordered data. Okay, that's why when we calculate for the median here, we have to order the data first or arrange the data from smallest to the largest one. Okay, because here it is about middle. We need to know which data or what value represent middle of data. Okay, so we have to order first your data, smallest to the largest, and then calculate. Okay, so we have two different formula for the median. First, when n is an odd, and second, when n is an even number. Okay. Okay. Okay, so n plus 1 divided by 2. Okay, for example that we have 5. Okay, so 5 here. So 5 plus 1, 6 divided by 2, 3. So x 3. Okay, x 3 here, not yet the answer. Okay, x 3 here is a data number 3 in order. Okay, data number 3 and in order. That's why we have to order the data. So 1, 2, 3. So 5 is your what we call answer. Okay, so median equal to 5, not 3 here. 3 here is a location of your data. So data number 3 in order. Okay, so here we have 6 data. So 6 data means that we have even number. So use the second one here. Okay, so 6 divided by 2 we have 3. 6 divided by 2, 3 plus 1 we have 4. So data number 3 plus data number 4 and then divide by 2. Data number 3 plus data number 4 and then divide by 2. Then you will have 6. Okay. So this is one of the method that we use to calculate median. Okay, if you have another method, then feel free to use. Okay. Okay. So then we have mode. Okay, so then we have mode. So mode is the most commonly occurring value in the data series. There is no formula for the mode. Okay, we just identify by ourselves lah, which one is the most occurring value in the data series. Okay, so if you have many data, for example that more than 50 data, so it will be useful or to key in the data in Excel, for example, and then you arrange the data, then we can see lah, okay, which one is the most occurring value in a data series. So sometimes there is no mode in your data series. Okay, mode is not exist. Sometimes we have single mode for the data set, or sometimes we have more than one mode for the data set. Okay, so usually we use mode for the qualitative data lah. Okay. Okay, properties of the mean and median, I think I will discuss when we go to the exercise. Okay. I'll put this in. So, I confused with my slide here. This one. Okay, we missed this one. Okay. Sorry, Okay. So identify the shape of the data distribution. Okay. Simbol tak keluar kat sini. Okay. Should be equal here. Should be equal. Greater than. Less. Okay. 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 So before this, you have the histogram to find or to identify the shape of the data distribution. Okay, the second method that we can use to identify the shape of the data by using mean, median, and mode. Okay, so if you can see here, we have when you have mean, the value of the mean equal to the median and median equal to the mode, then you will have symmetric. So this is the only three shape that we can get by using mean, median, and mode. You will get either symmetric or right skewed or left skewed. Okay, there is no bimodal, there is no uniform, there is no J shape, there is no reverse J shape. Okay, that one from histogram. Okay, but by using mean, median, and mode, we have these three shape. Okay, so you will have either mean symmetric, right skewed, or left skewed. So how we get symmetric? It is when the value of mean equal to the median and equal to the mode, the value of, okay, then you will get symmetric. For the right skewed, okay, the value of mean greater than median and median greater than mode, then you will get right skewed. Okay, left skewed, it is when the mean less than median and median less than mode. Okay, but when you have a real data, sometimes it will be not similar as to this pattern. So how to identify the shape when we have a real data? Okay, so real data, you will get what we call hilarious data lah. Okay, you will get variation of data. Okay, you mean data diverse. Okay, so what we can do, you can sketch. Okay, you can sketch your data, you can sketch the value of mean, median, mode here to identify which shape that you have. Okay, because sometimes, as I said, there is no mode in your data. So what to do? Okay, so how to sketch? Okay, this right. Okay. So mean always be the smallest, what we call, it's not smallest. Okay. Okay, so what we plot in x-axis, okay, what we plot in x-axis here, it is a value of mean, median, and mode. Okay, so the y-axis fixed. Okay, y-axis fixed. Okay, this is about height of the bar. Okay, so mean always be lowest bar. Okay, lowest bar. Median, moderate bar. Okay, and mode always be highest bar. Okay, always be. So y-axis fixed. Okay, what we plot is the value of mean, median, mode at your x-axis. That's the difference. Okay, so for example that, okay, if your real data you have this pattern, then it is okay lah. You can use this one, okay, to know what shape of your data distribution. Okay, let's say that there is no mode. Okay, mode is not exist. So what we have is a mean equal to, for example, we have 16, and median we have 17. Okay, so you plot here 16 and 17. Okay, mean the lowest bar, so lowest. Okay, and then median moderate bar, which is higher than mean, so higher than mean. Okay, so we add another bar here just to see what shape that we have. Okay, then you will have what here? Apa dia? What shape that we have here?
Negatively
Right.
skewed.
It is
Negative.
negatively skewed,
Negatively skewed.
negatively skewed or left skewed.
That's it.
Left skewed. Okay, so when you have your data, you can always plot, okay, what shape that you have when we use mean, median, mode. Because as I said, real data, it will be hilarious here. Okay, you could get the outlier. Okay, then you might not get this shape exactly as what we have here, the common one. Okay, so what you can do, plot. Okay, what we plot only on x-axis, the value of the mean, median, and mode. Okay, the y-axis fixed already. Okay, mean is the lowest bar, moderate, and mean, median, moderate, and mode is the highest bar. Okay, so you can plot. Question so far?
No.
Okay. So the properties of the mean and median you can read. I will discuss a few things here in your exercise. Okay, so number one, it is yours. You can do by your own. Okay, we go to the number two here. Okay, I hope that you already did your exercise. Okay, so A is just calculation. Okay, calculate the mean by using the formula. Okay, for the practice here, you can use what? You can do manual calculation lah. Okay, means that you find the summation of all the data here and divide by number of data. Okay, and then calculate the median. We have mode and then make range. Okay, that one easy lah. Okay, so use the formula. Okay, the B. So we go to the interpretation. Is the average value calculated in A parameter or statistic? Okay, so the mean here, it is S bar or mu? S bar or mu? Anyone?
Bar.
X bar.
Why?
Yeah, bar.
Okay, why S bar?
Selected
Select.
Selected country. So number of hospital for selected countries. Apa dia kita punya verbal kat sini? Verbal apa kat sini?
Number of hospital.
Number of hospital. So number of hospital, that's your verbal. Okay. X lah, notation. For the variable, only X. X bar is a sample mean. Okay, so why S bar? Because of for selected countries, so it is a sample data. Okay. So what is a distribution type that describe the data? Okay, so here for the C here, we have mode. Okay, so we have mode less than median and less than mean. So if you want, you can sketch mode, median, mean. So it is
Right skewed.
right skewed or positively
Positively skewed.
right skewed or positively skewed. Both is accepted lah. Okay. What is the best measure of average of this set of data and why? Okay. So the answer of this question, it is related to the properties of the mean and median. Okay. Okay, so the question is, what is the best measure of average? So the best measure of average, average is another name for the central of tendency. So your answer, it could be mean, median, mode, and mid-range. Okay, okay, but the apa tu? Mode just a accurate number, what we call the most accurate value in your data set. Okay, there's no calculation involved, and mid-range just a rough measure. So it will be either mean or median. Okay, so it is related to the properties here. Okay, the most important properties here that you should know: mean is affected by extremely high or low value. Okay, so extremely high or low value, it is the outlier. Okay, and median is affected less than mean when we have the outlier. Okay. Okay. So the best measure here related to how we identify the best measure here related to what shape that we have. Okay. Okay. So when we have symmetric, okay, and then when we have skewed, doesn't matter it is a right skewed or we have the left skewed. Okay. Okay, so both here skewed. Okay, so when we have symmetric data, okay, most of the data will be in range. Okay, so the probability that we are having outlier is low lah. Okay, when we have symmetric data. Okay, that's why when we have symmetric data here, the best measure of average will be mean. Okay, because mean less affected, because mean is more affected than median when we have the outlier. Okay, so bila dia tak ada outlier, mean is good to use lah. Okay, when we have symmetric data, the probability that outlier is in here is low. Okay, or maybe there's no outlier. Okay, so when we have symmetric, mean is the best one. Okay, because mean, it will be affected when we have the outlier. So symmetric, we could have no outlier. So that's why mean, the best one. Okay. But when we have skewed data, doesn't matter it's a right skewed or left skewed, or you have the J shape or you have the reverse J shape, it is a skewed data. Okay, when we have skewed data, most probably the end of the tail here, outlier, consists of outlier. Okay, most probably the end of the tail distribution here consists of the outlier. Okay, so that's why when we have skewed data here, median is the best one to use. Okay, because median is less affected than mean when we have the outlier. Okay, so to reduce the what we call the inaccuracy, then median is the best to use when we have skewed data. Any question? Why do you think median is less affected than mean when we have the outlier? Anyone? Anyone? Why do you think why do you think median is less affected than mean when we have the outlier? Cepat, kita ada banyak lagi nak discuss. Anyone?
Because median is determined by the position and the mean is by the sum of average of the sum of the number.
Because it is right lah. So because median is about location of data, so it will not really affected when we have the outlier, but mean it is about summation of the data. We calculate the summation of the data. When you have the outlier, it will be affected. Okay, let's see the example. Okay, I will add so that you can see. Okay, more clear lah why it is affected. Okay, so let's say that we have data set. Okay. Okay, so I want you to calculate the mean and also median. Okay, so let's say x bar 1, x bar 2 here. Okay, and then we add outlier. For example, 100. Okay, it could be the outlier. So 100 here, we suspect it is an outlier because it is isolated from the rest of the data set. Okay, when we go to the 1.4 letter, we do have some calculation how to determine it is outlier or not. Okay, so I want you to calculate the new x bar 2 and the new median 2. Okay, so do it now. In 5 minutes, and no, 2 minutes, I want the answer of the x bar and also median for the both. Okay, x bar 1 is a 5.2. Median x bar 2 is a 21. Median 1 is a 5. Okay. Median 2 is a 5.5. Okay. Sekejap ya. Okay. Can you see the difference? Okay. So the difference between median 1 and median 2, okay. What we call? Okay. Different median 1 and median 2, it is only 0.5. Okay, but the difference of the x bar 1 and x bar 2, it is about 21 minus 5, 16. 15.8. Okay, can you see the difference? Okay, so when we add the outlier here, okay, there is a huge difference between the x bar 1 and x bar 2. So means that your mean here affected by the outlier. Okay, but when we add outlier here, the median 1 and median 2, the difference only 0.5. It is affected but less than the mean here. Okay, that's why we have in the properties, median is less affected than the mean when we have the outlier. So 100 here could be the outlier. We suspect it as outlier because it is isolated from the rest of the data here. Okay, but when we go to the 1.4 letter, okay, so we do have some calculation to determine whether it is outlier or not. Okay, any question? Okay, okay, so how do we answer this question? What is the best measure of average of this set of data? Apa dia? It is median. Why?
Median because less affected.
Because
The
why it is less affected? Median because
the difference is not
it's not too much. Yeah,
so much.
okay.
Yes.
But here we don't really compare the mean and median. So why? What is the real reason here? We said that median is the best measure to use. We cannot talking about the outlier because we don't identify any outlier here. We don't try to identify whether there is outlier or not in this data set. So what is the real reason here? Why we use median, the best one? Because we have because it is
We have many data
because
we have many data.
any data not related to that. Okay, so median, some of your friends already answered it because it is skewed data. Because we have skewed data. Median, since it is skewed data. Okay, so it doesn't matter you have right skewed or left skewed, it is a skewed data. So whenever we have skewed data, the best measure to use is a median. Okay. What happens if you have a symmetry here for the distribution? So the best measure is
Using mean.
mean. Okay. So when you have symmetry here, then the best measure to use is a mean. Why mean? Because it is symmetric data. Okay. So we go to the next one. Any questions so far?
No.
No question.
Okay. So the second measures that we have here is a variation, or we call it as a dispersion. So why we use this measure, as I said, to discuss the variability in a data set. So kalau tak faham what is variability, it is about how consistent is your data. Okay, your data will be consistent if your data close to each other. Okay, so most of the data means that we have some range of data. Okay, they are close to each other, then you will have consistent data. Okay, so how close they are to each other, variation that we use is a probability. Okay, variation. Okay, to discuss how close is your data, how consistent is your data, how the spread of your data, okay, and so semua tu it is a probability, okay. The terms that we use is a probability. So we have four measures here. We have range, variance, and standard deviation, and we have a new measures that we introduce here, coefficient of variation. Okay, so range, variance, and standard deviation here. These three we use when we compare similar variable. Okay, means that let's say that we have population A, we have population B. Okay, so both the data that we can collect is in kg. Okay, so in kg, similar variable, similar unit. Okay, it is a similar unit, then we use these three measures. Okay, we use these three measures, either one. Okay, when we compare similar unit. Okay, similar unit, then we can use these three measures, either one. You can calculate the range, okay, simplest measure of variation. You can go to the variance or you can go to the standard deviation. Okay, so when to use coefficient of variation here? So we use coefficient of variation when we compare different unit, okay, different variable. Okay, let's say that we compare kg versus cm. Okay, so two different unit, then the only measure that we can use is a coefficient of variation. You tak boleh pakai range, you tak boleh pakai variance, you tak boleh pakai standard deviation. Okay, and also as I mentioned before, quanti also we can use to measure the variation. So quanti, based on quanti also, we use that one only when we compare similar variables, similar unit. So the only measure that we can use is a coefficient of variation when we compare different variable, okay, different unit. Okay. So measure of variation may help researcher to describe data more accurately lah. Okay. So usually, okay, when we try to compare which one is the best data, we go to the variation. Okay. Okay, so variance and standard deviation are used quite often in inferential statistics. Okay, when we go to the chapter 2 onwards, we will use a lot variance and standard deviation. Okay, in fact, these two values will determine which formula that we need to use. Okay. Okay, so you have the range here. Okay, just a simple one. Okay, we have the variance. Okay, hilang dah semua ni. Okay. Okay, so here should be sigma square, summation of S. Okay. Okay, so that's why in your calculator we have two different values for the population and variance because we have different formula here. Okay, the different at your denominator. Okay, population variance divided by capital N and sample variance divided by N minus 1. So N tolak 1. That's why we have different value. Okay, that's why your calculator, we have two different value for the population and sample. Okay, so standard deviation just a square root of the variance. Okay, So the variance and standard deviation here, it is about average of the square of the distance each value from the mean. Okay, when we interpret the variance, okay, let's say that you need to interpret the variance. You have single data. Okay, if you have more, two and more, then we can compare those variance lah. Which one is the best data? Okay, but when we have single data, when we interpret the variance, it is about average of square of the distance each value from the mean. That's how we interpret the variance. Okay, when we have single data set. Okay, when we have two and above, then we go to the comparing the variance between data set. Okay, but when we have single, okay, it is about average of square of the distance each value from the mean. Okay, so standard deviation just a square root of the variance. Okay, so properties of the variance and standard deviation. Okay, so variance is always positive, standard deviation is always positive. There is no negative value for both. Okay, so there is no unique for the variance. Okay, doesn't matter what unit that you have. For example, that for data we have kg, but when we calculate the variance, there is no unit. So kita tak boleh pakai kg as a unit for the variance because it is a dimensionless. Okay, no variance, no unit for the variance. Kalau you tulis unit, salah. Okay, but there is a unit for the standard deviation. Okay, so the unit of the standard deviation, it is similar to the unit of the data. So if your data in kg, then unit for the standard deviation will be in kg lah. Okay. Okay. If the data value are near the mean, the variance will be smaller. If the data value are far from the mean, the variance will be larger. Okay, that's how we define the consistency of your data. Okay, when variance smaller, then we have a good consistency of the data. If the variance larger, then your data will be inconsistent lah. Okay, if we can sketch here, if we compare, okay, so mean here, let's say mu or S bar. Okay, mu or S bar. So this is your data. Okay, so if the data here close to the mean, means that we have smaller variance. Okay, so if the data here far from the mean, means that we have larger variance. So if we compare, okay, if we have smaller variance, then the graph will be like this one. Okay, it will be shrink. Okay, it will be shrink. Your graph here will be shrink, means that the data value here will be close to the mean. So variance smaller. Okay. When you're plotting here separate, then we have larger variance. Okay. So coefficient of variation. Okay, so we have similar formula for the population and sample. It is about it is about standard deviation divided by mean. Okay, and it will be in terms of percentage. Okay, for the CVR. So coefficient of variation. So we use to compare when the unit are different. So means that we have different variable. Okay, so when we try to compare durability of the different variable, then we go to the coefficient of variation. So you tak boleh pakai range, we cannot use standard deviation, and we cannot use the variance. Okay? Okay, so why we go to the measure of variation? Okay, we also can use the mean, okay, to discuss the data. But sometimes the mean cannot be used, okay, when the measure of central tendency do not give any significant meaning. So for example that we have similar mean, okay, so like this one. We have group A, group B. So both group have same total number of students. Both we have 6 data. Okay, so students are given the same set of tests and the mean of score is calculated as 66.67 for both. So means that the S bar here, S bar for the A 66.67 and S bar for the group B also 66.67. So we have similar mean, means that it is not significant to use mean to discuss the data here. Okay, so that's why we go to the variation. Okay, so we try, if we have different mean, then we can use mean to compare which one is a good data. Okay, which one is a good data, group A or group B. Okay, higher mean because this is about sorry, it is about score of data. So higher score, better data lah. Okay, but here similar mean, so we cannot use mean to discuss, to compare which group is the best one. Okay, which one is the good one. Okay, so we go to the variation. Okay, so you can use the simplest measure of variation, which is range. So range of A, range of B. So range of A, it is 90 minus 30. So 60. Okay, range of B, 85 minus 50. So we have 35. Okay, so how we know which one is a good one? Okay, you can compare the range here. So how do we compare durability? As I said, the smallest one, the best one. The smallest one, the good one. The smallest probability means that we have consistent data. Okay, so based on the range here, so range for the B less than range for the A. Hence, group B is more consistent or less separate. So we can conclude here, group B is the best one. Okay, because we have smaller probability on group B. Okay, if we what we call, so bar visualization point, you can see here the data for the A, they are far from each other, and the data for the B, they are close to each other. Okay, so means that it is more consistent. Okay, so to confirm that, we calculate the probability value. So you can use the range, you can use the variance, you can use the standard deviation. Why? Because it is about similar variable, score of test. Okay, so since range of B smaller than A, then B is more consistent. So B is a good one. Any question so far about durability? So the smallest one, the best one. No, so I proceed.
Understand.
Okay. So how do we compare? So this is how we compare. This is terms that we use when we compare durability of the data. Okay. Tak keluar pula. Okay, let's say that we have sigma 1 less than sigma 2 here. Okay, so same interpretation is applicable for the range and variance, also for the CVR. How do we interpret CVR? Also similar, because this is about probability of the data set. Okay, as long as the smallest one, it will be less dispersed, it will be less spread, less variable, more consistent, more precise, more accurate, and better data with smaller standard deviation, smaller range, smaller variance, and smaller CVR. Okay, similar, I jump sikit. When we go to the quantile, you will have inter-quantile range. Okay, so you should know lah because you already go through that one. So inter-quantile range, okay, it is about Q3 minus Q1, third quantile minus first quantile. Okay, so inter-quantile range also we use to compare the probability. So similar to the IQR here, how do we interpret? Similar. The smaller the IQR, the better the data it is. Okay, less dispersed, less separate. So you have to be well known with the term here. Okay, in your assessment letter, okay, we could use one of these terms. No? So you should know. When we say less separate, what does it mean? So smaller standard deviation. We need smaller variability. Okay. If we say which data is more accurate, means that we need data with the smaller probability. Okay. If we say which data is more separate, okay, so means that we need the data with larger probability. Okay, that one you have to master. You have to be well known with the term that we use here. Okay. Okay. So we go to the exercise, okay, number 1 and 2. Okay, if you have any question, you can always interrupt me. Okay, we can discuss. Okay, so which of the following set of sample data is less variable? Okay, which of the following set of sample data is less variable? So the keyword here we need to know less variable. Okay, the less variable here. So how do we define which one is the less variable? The value that we can use is not like that. Okay. How do we know the sample data is less variable? It is based on variability. Okay. You have to learn. Okay, it is not because this exercise under the measure of variation, you have to, then you know, you have to calculate the probability. Okay, tak boleh macam tu. You have to understand why this question we have to calculate the probability to answer it. Okay, why in this question it must be probability. Okay, you have to understand that one. Okay, because when we go to the assessment letter, it will not mention this question from which subtopic. No. Okay, you have to know by your own what value that we have to calculate here to answer this kind of question. Okay, that one you have to understand why we have to calculate the probability here. Okay, it is not because this exercise under this subtopic then you just jump to the probability. No. Okay, tak boleh. Cannot be like that. You have to understand why we need to calculate the probability. Okay, so it is because the keyword here, the less variable. We need to know which of the sample data here is less variable. So to know that, the only value that we can calculate is a variability. What value that we can calculate here? Okay. So the data here, it is about method A and method B. So similar variable, method A, method B. Just type of method, but it's still method. Okay. So it is not mentioned here what kind of data that they collect here, but it is about method. Okay, we try to compare the method. So it is, we assume that similar variable. So you can calculate the range, you can calculate, so sample data, you can calculate the S or you can calculate the S square. Either one will be accepted. No need to calculate all those three, okay, only one of them. Okay, either one will be accepted. But if you calculate the CVR, salah lah. Okay, because CVR it is for the different unit. But here we have same. It is about both, it's about method. Okay. So calculation is easy. As I said, you can always refer to the formula how to calculate. Okay. So starting from this, okay, if we go to the manual calculation for the standard deviation and also variance, it will be quite complicated. So practice yourself to use calculator. Okay, so key in your calculator and key in the data in your calculator and then get the value. Okay, if you can see, I will show here this calculator, this kind of calculator. Okay. So before you key in anything, just clear, reset everything in your calculator. If not, the data will be mixed. Okay. So if you use this kind of calculator, okay, you go to the mode here until you have the SD. Okay. So SD number 1. So you press 1 lah. Okay. So to key in the data, okay, let's say that for the method A here, we have 79. 79 and then M plus. You press on M plus and then dia akan keluar N equal to 1. Means that one data already key in your calculator. Okay, and then we continue 73 M plus. So 2 data. And then how to get those value? You press on balik. Okay, and then go to the shift 2 if I'm not mistaken. So shift 2, you will have first here S bar. So if you need the, I don't know whether you can see or not, but you can always refer to the step in your module or in the slide note. Okay, so the first, what we call the first value here is a mean. So it doesn't matter you have population data or sample data, this is your mean. Okay, the second value, population standard deviation. So in this case, kita tak boleh pakai this value because it is clear that it is sample data. Okay, so we go to the third one, sample standard deviation. So number 3. So you have your answer. Okay, this is a standard deviation. If you need variance, then square that value, then you get the variance. Any question?
No.
Okay, so I will just use the answer here. So here the answer is a standard deviation. So we have SA equal to 36742 and use for decimal places. Okay, in your calculation, in every calculation, at least 4 decimal places. Less than 4, I will deduct your mark. Okay, in quizzes, tests, and final, less than 4 decimal, I will deduct your mark. Okay, so make sure that you use 4 decimal places. So 78493. So we calculate the value, then the next step is to answer this question. Which of the following set of sample data is less variable? Okay, so we already calculate the value, so the next step is to compare. Okay, so here we have SA less than SB. So means that method A, apa dia? If we use notation less variable ni, method A is, if we use the terms variable here, method A is, anyone? Less variable. So method A is less variable. Okay, because less variable here. Less variable here means that we need data with smaller variability. Okay, so S because of SA less than SB, then method A is less variable. That's the answer of this question. Okay, compare, calculate the value, what value that related to that terms. Okay, you can choose. It doesn't matter you use range, standard deviation or variance. Okay, you have to conclude same thing. The conclusion must be similar because it is about similar data set. Okay, and then after you get the value, compare which one smaller one, or you can compare which one is the highest one. It's up to you. Okay, so what we do here, SA less than SB. So method A is last variable. Okay, so number 2. Okay, the following set of sample data represent the battery lifetime from 2 different brands. Which brand of the battery is perform better? Okay, what is the variable here? Anyone? What is the variable?
Battery lifetime.
Battery lifetime.
Battery lifetime in hours. Okay, so variable is a battery lifetime. Okay. Okay, so which brand of battery is perform better? Okay, so we need to know which one perform better. So what value that we have to calculate to know which one is perform better? So variability lah. Okay, variability. Buruk tulisan. Sekejap bagi sikit. Okay, so here it is about battery. Okay, same variable has been collect. We have battery lifetime in hour. Both is about hour, so you can use either one, range, S or S square. Sample data. Okay. Other than variability, what we can calculate here to compare which one perform better based on what we have discussed before?
Less variability perform better.
Okay, so less variability perform better. Okay, so means that we calculate variability, isn't it? Okay.
Yeah.
Other than variability, what kind of value that we can calculate to know which brand of the battery perform better?
Interquartile.
Mean.
Interquartile. Interquartile still variability. Other than variability, it is? Macam dah dengar jawapan tadi, anyone?
Shape distribution.
Shape of the distribution, okay, you can do that, but in order to determine the shape, you can draw the histogram or you can calculate the mean, median, and mode lah. Okay, other than shape, what kind of value, okay, that you can calculate here to know which battery is perform better? Anyone? Central tendency. Okay, what value of the central tendency we can calculate here? It is
Mean.
mean. You can calculate the mean here to know or to identify which brand of the battery is perform better. Okay, the keyword here is perform better. Okay, so you can go to reliability because by using reliability we can know which one better, and also mean. Okay, so what mean that we need so that battery perform better? How the mean it is? We need larger mean or smaller mean? Okay, so for the
Larger.
probability should be larger mean. Kenapa larger mean? Why it is must be larger mean? Why?
Perform better.
Perform better. Okay. Okay, perform better is an important keyword. Okay, important keyword. Yeah, related to how the mean it is, but we have another reason why we need larger mean, so that we know which battery perform better. Okay, we know that probability always smaller one. Okay, perform better or better data probability must be smaller. Okay, it is clear here. Probability must be smaller, then it is perform better. So mean, your friend said larger. So the mean here, we need larger mean. Why? It must be larger mean. So one of the reason because of the perform better lah. Another one,
The variable battery lifetime.
because of the variable. Because
Variable.
of the variable. Variable is very important. Okay. So variable is about battery lifetime. So it will be perform better if the lifetime is longer, isn't it? That's why we need larger mean. Okay. Some variable, even though we have performed better, even though we have performed better, for the some variable, we need the smaller mean. For example, that we have the simple one. Number of, let's say that the data is about number of defective item. Let's say that we have A here is a we have different production line, for example, or conveyor, for example. So the data that we collect is the number of defective item. Okay, so how do we know which production perform better? If we have number of defective as our variable, what happened to the mean? Mean must be
Small.
smaller. Mean must be smaller. Then it is perform better. Okay, so variable is very important. Okay, that's why I highlight lah. Okay, you need to know how to identify the variable. Okay, dia akan mempengaruhi the value that we need to. We need larger or we need smaller. So similar when we go to the chapter 3. Okay, still far but it's okay lah to discuss now. Okay, so chapter 3 letter, when we go to chapter 3 letter, variable is very important because the variable itself will determine your hypothesis tu nanti dia akan greater than ke, dia akan less than ke. So similar to this, the mean. Why we need larger mean? Of course, the keyword here is a perform better. Okay, the keyword perform better here contribute to the mean. Okay, and another one is a variable. Larger because the variable is a lifetime. So better means longer lifetime. That's why we need larger mean. If we change the variable, then it will be different. Okay, number of defective perform better means that smaller number of defective item. That's why we need smaller mean. Any question? Okay, so for this question, you can calculate probability, you can calculate the mean. Okay, because it is general question lah, general question. Just perform better. Unless you ada macam question 1, specific terms, less variable. Or maybe here, less consistent. Okay, then we go to the probability. Okay, but here is a general one, just perform better. It's up to you. So dalam quiz ke, dalam test letter or final, both will be accepted lah, whether you calculate the mean or whether you calculate the probability. Okay, so the answer I leave it to you. How we answer the question 2 similar as what we did for the question 1. Okay, what I want here, I want you to understand why we calculate that, why we calculate this. That one important. Why we do this, why we do that, why we calculate variability, why we calculate mean. Okay, that one is important lah. Okay, the answer is already here. We have the S, and then you compare, and then you state which one is the perform better. So here as A greater than as B, so mean that brand B is perform better lah. Okay. Okay, so this is for the CVR. Okay, compare the variation of the age and income. So age, okay, so we have different unit, age and income, okay, year and also the RM. So the only value that we can calculate for the variation is a CVR. Okay, so you are given information here. Okay, so calculate for the CVR and then compare. Okay, so for the compare here, then you can state which one is a more consistent, for example. Okay. Okay, so accuracy and precision concept. Okay, it is related to the variability. Okay, so the accuracy here, it is about how close a measured value to the true measurement. So in our case, how close your data value to the mean. Okay, to the mean. Okay, accuracy means that how close your data value to the mean value. Precision here, how close the data value to each other. So we use the concept of variability. Okay. So we have example of game of that here to visualize how it is accurate, how it is precision. Okay, and we have the exercise here, whether it is accurate or precise. Okay, number one, just a quick exercise here. Number one, accurate or precise? Just anyone?
Precise.
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 Precise. Okay. Okay, precise. B?
Accurate.
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 Accurate. So we have one arrow, so accurate. C?
Precise.
Precise. Accurate. D?
Precise.
Precise.
Precise and not accurate. And E?
Accurate.
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 Is it precise?
Yes, both. I think one value.
Both.
Only one value.
Both, madam, both.
Okay, but I
Yes.
think it's only accurate because we don't know the value here. The measured value. Kita tak tahu the measured value here because like we discussed just now, mean similar but consistent different. The consistency different. They are okay. The group A, the group B similar mean, but the consistency different. Okay, so similar to here. We just know the mean. Okay, so mean similar to the actual value, so it is accurate lah. But we don't know the measured value, so we cannot say that it is precise or not. Okay, so just accurate. Okay. Okay. So we have the last measure, we have measure of position. So we have percentile, we have decile, we have quantile. Okay. So because of it is about position, automatically you have to audit the data first. Okay. Don't forget to audit the data. Okay. Because it is position of data. Okay. So percentile means that we split the data into 100 equal parts. Decile split the data into 10 equal parts, and quantile split data into 4 equal parts. Okay. So we use percentile a lot for the education. Okay, for example, okay, to know the position of the student. Okay. Decile, we don't use a lot that decile. Okay, but quantile, okay, also we use for the variation, as I said, and also for the box plot letter in 1.4, okay, the quantile. Okay, so the formula is similar for all these three. I is what position that you want. In 100 part, so which part that you want? 75 or 18, for example. That's I. So similar to the sign, which part that you want? Okay, quantile. And number of data. Okay, small n here, number of data divided by 100 for the percentile because we split into 100 equal parts, and then the sign we split into 10 equal parts. That's why divide by 10 and quantile divide by 4. So at C here, it is a position of your data. Okay, position in your data. So C position, C data number C in data lah. Okay. Okay. So we have formula for the C here. C is a position of the data value. Okay. Not yet the answer. Okay. We have formula for the C. If the C not a whole number, round it up to the next whole number. For example, when you calculate, okay, when you calculate percentile here, you get at C here. Not whole number means that decimal places. Let's say that we get 5.5. Okay, so 5.5 not a whole number, so we round up. So it will be at C. To the next whole number. Kita round up to the next whole number. Tak boleh round up to the, okay, we don't use the common rounding lah. Okay, you just round up to the next whole number. So at 6. So means that data number 6 in order. That's your answer. Okay. You see the whole number, then use this formula. Okay. Okay. It should be C plus 1 here. Okay, you can refer to the unit lah. Okay. So let's say, yeah.
So kalau contoh data 5.2, kalau round out
6
juga. Okay.
6 juga. Kita tak pakai that common rounding. Okay, you just round up to the next whole number. Even you have 5.1, even you have 5.0001, still 6 because we need to round up to the next whole number. Okay, clear? Okay, if C the whole number, what to do? Let's say that you get C here, 5, as 5. So 5 is a whole number. So we plus with the next number, which is at 6. And then divide by 2. Then you will get your answer. Okay. So here, this one, when we have C is not the whole number, and this one, when we have C is a whole number. Okay. For all these three measures, percentile, decile, and quantile. Okay, so this is the example. You can go through. Okay, this is the exercise. Sekejap sebelum tu. Okay, so you can read here why we need measure of position. Okay, and quantile, as I said, is a rough measure of probability. Okay. Okay, so quantile here, interquantile here, it is a Q3 minus Q1. Okay, so you will get IQR. So how it is, we can use that one to measure the probability in a data set. So how we discuss that, how we interpret that, similar as range, variance, and standard deviation. Okay. Okay, so this exercise, okay, the step 1 is, step 1 here is to order the data. Okay, order the data smallest to the largest, and then you can proceed. Find the value correspond to fault design. So means that we need D4 here. Okay, D4. So X4 times 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 data divided by 10 because of design. Okay, so order first. 1, 2, 3, 4, 4, 5, 6, 7, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So 4 times 9 you will get divide by 10, so 3.6. So X 3.6. Okay, not a whole number. Okay, so we round up to the next whole number, X4. So data number 4 in order. So 1, 2, 3, 4. So coincidentally you have 4. Okay. Find the value correspond to the third quantile means that we need Q3. Okay. A teacher give a 25-point test to the 10 student. The score are shown below. So we have the score. Find the score correspond to the 20th percentile. So we need P20. Okay. And here is a D7. Any questions so far?
No, Doctor.
Okay, so yeah, I try to okay, let's try to arrange this data. 3, 9, sorry, 7. 11, 13, 15, 16, 18. Okay. So P20 here equal to 8. Here. This about here, right? Okay, so means that what we can interpret here, okay, because percentile always used in education. We can discuss the position of student in class. Okay, so P20 equal to 8 means that the location is here. So what we can say, the rest of the student here, this is student because it is about score of the 10 student. So the score of the 10 the student here. So the rest of student here, 1, 2, 3, 4, 5, 6, 7.
14. 14. 13.
Oh, the finger, yes, thank you. Okay. So these 8 students, okay, they score better than 20% of student in class. One of the interpretation that you can write for the percentile. Okay, so because P20 it is equal to the 8. 8, the position is here. So what we can write here, these 8 students score better than 20% of students in class. These 8 students, they are in top 80%. Okay. These 2 students, they are in bottom 20%. Interpretation that you can write. Okay, for the percentile. Any question? Any question for the today class? I think that's it, the subtopic for this week. Okay, so next week we will continue with the 1.3.4 until refer to the teaching plan. No question currently. Okay, so you can try the tutorial question if you already have your module. Okay, if not, try to redo the exercise if possible. Okay, to get to understand more about the topic that we discussed today. Okay, I rasa dah tak ada yang tertinggal kot. If anything, you can always ask me. Okay, if you do your tutorial question, satu lagi. Sorry. Okay, I insert here. Okay, just now we discussed the best measure of average. Okay, so now what is the best measure of variation? Okay, so tadi we discussed the best measure of average. So now what is the best measure of variation? Okay, so similar when we have symmetric and also when you have skewed data. Okay. So both skewed here and here symmetric. Okay. So we know that when we have symmetric, mean is the best one because mean less affected than median when we have, mean is more affected than median when we have the outlier. That's why mean the best use for the symmetric and median for the skewed data. Okay, so for the best measure of variation, okay, so we have here, it is between whether we use variance or standard deviation and also IQR. Okay, it is between variance or standard deviation or IQR. Okay, so similar lah if you have CVR, also similar here. Okay, because variance, standard deviation and CVR range, it is about we do not consider the range because it is a rough measure for durability. Okay, so variance, standard deviation and CVR. Okay, the formula used for the variance, standard deviation and CVR related to the mean. Okay, we use mean to calculate the variance and standard deviation, and also we use mean to calculate the CVR. Okay, and IQR is about position of the data because it is about quantile. So similar reason to the mean and median. Okay, when we have symmetric data, the best measure to use is these three for the symmetry, because they will affected more when we have the outlier. Why? Because of the mean. Okay, because mean contribute in the formula of variance, standard deviation and also CVR. Okay, but when we have skewed data here, the best measure to use IQR. Why? Similar reason to the median, because it is about position of the data. Okay, when it is about position, then it will be less affected when we have the outlier. Okay, question? I think that's it. But if you go through the tutorial question, you have any question, you can always text me. And I just want to say, please try to text me during the office hour to get fast response. Okay, after the office hour, if I think the question that you ask is not really important and we can wait for tomorrow, then I will reply tomorrow. Okay, some of you already experienced that. And also during the weekend, try not, if it is not really important, try not to text me during the weekend. you will get late response for sure. And but I think because of the assignment last weekend I'm quite stressed tengok you punya WhatsApp. It is because I have 3 sessions dan it's quite nilai. Okay, so try to text me within the office hour to get fast response. Okay, if not, maybe you will be late response. Okay, any questions so far for this for today class?
No.
No.
Macam no dia tu. Faham lah
Not for.
Okay.
No.
I think that's all for today. Thank you. See you next week. InsyaAllah. Thank you.
Thank you,
Thank you.
Thank
Doctor.
you, madam.
Thank you.
Thank you, madam. Thank you.
Thank you.
Thank you, madam.
Okay.
I don't know attendance.
I will do it next week lah, and it will be abandoned. It will be backdated lah from week 1 until week 3. Okay.
Alright.
Thank you, madam.
Thank you, madam.
Assalamualaikum.
Thank you,
See you next
madam.
week.